Assalamu alaikum. My name is Ali Khan, roll number 21 TE77. Today we have discussed the lab number 2 of DSP. So first of all we start from the task number 1. In task number 1 we actually plot discrete function. So first of all we have three constant defined as n0, n1 and n2, which are valued with -1, -3 and 3. So -3 and 3 basically is the range of the plot. After that n vector range from the n1 to n2, and we have x which have condition for discrete plotting. We use stem command, and after using this command we get output is shown in this figure. So now we move to the task number 2. Here task number 2 is also same like previous task with some differences. First of all, we define three constant n0, n1, n2, which are valued with -1, -5, 5. These are the range of the plot. Similarly, we define a vector from n1 to n2 and nx. We give the condition and for plot we use stem command, and we get output is shown in this figure. So now we move to the task number 3. In task number 3 we have two constant n1, n2 valued as -3 and 3, which show the range of the plot. We use n for range, and we define x is equal to 3 multiply 0.5 whole power n, and use stem command for plotting. So here in the second part, n1 n2 is equal to -10 to 10, and n is equal to -1 n1 to n2, and using stem command, and the output of both shows in this figure. So now we move to the task number 4. So here in task number 4, we actually plot unit impulse. So for that we define a function x is equal to unit impulse n0, n1, n2. We define a vector from n1 to n2 and define x which is equal to n is equal to n0, and then n over function. And for calling our function, we call our function n is equal to unit impulse, and then we give some values 0, -5 to 5, and we use stem command to plot discrete graph. After that we get an output only in one plot. So now we move to the task number 5. So here in the task number 5, in task number 5, in this task we actually plot unit stem function. For that, first of all, we define a stem a function and then use if loop n not is equal to 0 and then end of our function and then define our function x with given condition and giving the value from -5 and 5 and we get the output is shown in the figure. So now we move to the task number 6. In this task we add unit step and unit impulse functions. For that first we define n, which is our range of the function, which is -3 to 3, and x1 is unit step and x2 is equal to unit impulse. Then add both and then we use command to display the result. So now we move to the task number 7. Here in this task we actually flip our function. So first we define range, which is from -3 to 3, and then define array and then flip this array subplot and then use stem command to display discrete function and then give subtitle, which is original signal and axis. Use subplot, then stem and then title flipped signal. Then we get output as shown. Now we move to the task number 8. Here in task number 8 we define a signal array 1, 2, 3 until 7 and then we scale our signal. So we give scale function factor, which is 2, then plot the signal, then hold on and then plot the scale signal is shown in the figure. Now we move to the task number 9. Here in task number 9, in this task we shaped our function. For that first we define time, then define our function, then shaped our function and then use plot command and hold on, then plot the shift signal and then we get the output is shown in this output. Here this is the original signal and this is the shift signal. Now we move to the task number 10. In this task we define zero hold order function. For that first we define line space and stem define and then define frequency, then define our function, which is sine function, then define time, then use frequency formula, time formula 0 scale, then starting for loop, then end our for loop, then use subplot and use subtitle and subplot again. Then we use stem and give some title. After that we get the output in continuous and discrete as shown in this figure. So now we move to the task number 11. So this is the last task In this task, we have an input signal that is 1, 2, 3, 4, and 5, and we define time which is zero point 0.1. Then we define n and output signal, then starting for loop, and we define output signal. Then we use subplot, stem function, and title. After simulation, we get input signal as well as output signals. This is input signals and this is output signal. So all these about lab number 2. So thanks for watching.